Alrighty, before we move on to lesson 7.2, I wanted to finish up a couple of questions on 7.1, looking back at number 87. It says the floppy disk drive was invented in 1967 to store information for computer users. The first floppy drive used an 8-inch disk and had a radius of 3.91. So we have a radius of 3.91 inches. The drive motor would spin at 300 rotations per minute. The part A here is asking to find the angular speed. Figured we need another problem on angular speed of the 8-inch disk in radians per second. So we want radians per second. So what we need to determine is, remember, a full circle would represent 2 pi. So to put this in seconds, we would need, for angular speed, which is your W. Again, I'm not quite sure how to use that formula, but using common sense, a full circle would be 2 pi times how many rotations can happen in 1 second. So you have to take your 300 rotations per minute, and there is then 60 seconds in 1 minute. So to actually write this out a little bit better so you can see it, we'll do rotations per 1 minute. So to get rid of the minute there is 60 seconds in 1 minute. So then the 1 minutes would cancel. Oh man, that minutes, there you go. And so therefore what I'm really doing here is doing 300 divided by 60 to determine how many rotations per second there are. So when we do that, we get 5 rotations per second. So to finish out this angular speed, if I go around a circle in 2 pi and I can do it 5 times, then my angular speed would be 10 pi radians per second. All right. And then in part B, it says find the linear speed. So linear speed is our V of a particular point of the circumference of the 8-inch disk in inches per second. So we need it in inches per second. All right, so our V here can be written as S over T. And then to find the S, it is R times theta. So our radius here is 3.91, and we determined that our theta is 2 pi. And then from there, we need it in seconds. So let's get some math done first. So let's go with 3.91 times 2 times pi. And we get 24.57. And then this again for the arc length, since the radius, that would be your inches. So I want inches per second. So there's 24.57 inches. And then per second here, well, actually, I guess instead of using this per second here, we already have our W. We could actually use, we'll make this a little bit easier. Linear speed has 3 formulas, so we can do R times W. And this time, my radius is 3.91. And then I have the 10 pi, which will include the 2 pi already there. And then now I can get an easier answer rather than to do a fraction over a fraction and keep change flipping all that stuff. So 3.91 times 10 times our pi, and we would get 122.84. And this again would be inches per second. Okay. So I figured I needed to do another angular speed just so we have a better example. Again, I'm not quite sure how to use the formula out of the book, but using the common sense here of how many radians we go around and how many times we can do it will give us our radians per second. And then from that, using the linear speed, we can take that angular speed times our radius to get our linear speed. Right? There's just a few more I wanted to go over that we didn't get to touch base on, and that's number 91. And this is talking about area of a sector. So area is r squared times theta divided by 2. All right, so we are told to find the area of a sector of a circle where the radius is 7 centimeters with a central angle of 70 degrees. All right, so what we're going to do here is we're just going to kind of plug things in. So we have area is 7 squared. Theta, we do need to write this in radians. So I'm going to take this, I'm going to do pi over 180 degrees. And we would get approximately, let's see, 70 divided by 180 times our pi. And we would get about 1.22. So we'll take that answer times 1.22 divided by 2. So that's what we're going to do. Again, that's a simplified version. I'm going to keep it as is, times that by 49, since that's what 7 squared is. Divide that result by 2, and I get the 29.93. 29.93. And again, this is area, so this would be centimeter squared. All right. So again, theta, again, has to be in radians. And then you just kind of plug it in and just go. Let's do another one to make sure we got it. Looking at 93, it says find the area of a sector of a circle with a radius of 4 meters with a central angle of 3 pi over 5. Already in radians, so all we got to do is go straight into plugging it in. And again, to be as accurate as you can, I would probably do 3 divided by 5. Then multiply that to your pi, and then multiply that result to 16, since that's what 4 squared is, and then divide that by 2. So that gives me, what's that, 15.08. And this again was meters, so this would be meters squared. So again, area, super easy, just plug in the information, but that angular speed, I just wanted to make sure I had another example of that. And I think that was pretty much it. The next type of a question was, again, just looking at linear speed, and I think we've done enough of those. So let's get in then into lesson 7.2, which will be trig functions and right triangles. One thing that I have learned about teaching pre-cal is pre-cal assumes you already have a trigonometry background, like you've taken a whole course on it. So a lot of things are assumed that you know. So what I actually would like to do is kind of just explain some things maybe you just remember from your geometry course or from your Algebra 2 course or any other course that you've taken prior to this math course. All right, so you might have heard this saying when talking about trig is so ka toa. And basically, this is just a helpful reminder of how to break down our trig functions. So is basically just sine of theta equal to the opposite side divided by the hypotenuse side. Ka is the cosine of theta equal to the adjacent side divided by the hypotenuse side. And then toa is the tangent of theta equal to opposite over adjacent. A couple other things. When I write SI in, I'm writing short for sine. When I write COS, this is short for cosine. And when I write TAN, this is short for tangent. All right, so and the way we get all these is you take any right triangle, doesn't matter how you draw it, as long as there's a right triangle to it, put a theta randomly anywhere. You can put it here or you can put it here. The ratios will always remain the same. But wherever your theta is, the side that's opposite of that theta is your opposite side. The side that's opposite of 90, or what we call the hypotenuse side, is your hypotenuse. The last side, which is next to the angle that's not the hypotenuse, is called your adjacent. So when given information, you can just plug it into these ratios to find out what these trig functions are. Another thing to remind you is inverses of these guys. So if I wanted the inverse, which it will be 1 over sine theta, we could also write it as cosecant of theta. If I want it 1 over cosine theta's inverse, that is written now as secant theta. If I want it 1 over tan theta, this would be the same thing as cotangent theta. Now, with that said, cosecant being the inverse of sine, we'll just flip this fraction. So cosecant's ratio is hypotenuse over the opposite. Secant's ratio would be hypotenuse over the adjacent. And then the cotangent's ratio would be the adjacent over the opposite. All right. And then there's one last topic that we'll talk about, and you'll see this DMS. This represents degrees, minutes, and seconds. And I'll explain how you work those out. But without further ado, let's do some examples from 7.2. So let's first look at number 1. You are asked to use the information contained in each figure to determine the values of the 6 trigonometric functions. All right, so it's not a hard task, but these questions are going to be tedious because you're looking for 6 answers. All right, I'm not the best drawer, but you get the idea. So this is my theta. And then you're told this is 2 square roots of 2, and you're told that this is 4. All right, before you can actually solve for all 6 trigonometric functions, there is some pre-work that you have to do. And this is what we call, again, I don't remember if y'all remember this guy, but the Pythagorean theorem. Most of the times when I talk to high school kids, they simply say, oh, I remember that. Don't remember what it's used for. Pythagorean theorem is used to find a missing side of a right triangle. The formula there is written as a squared plus b squared equal to c squared. All right? So it doesn't matter what you label as your a or your b. The only thing that matters is the hypotenuse, or the side opposite of the 90-degree angle, has to be the c. The c has to be the hypotenuse. So what I'm going to do is I'm going to write this as 2 square root of 2 squared plus b squared, since that's my missing side, equals 4 squared. When you're working with radicals, it does go to both. So this is 4 times a square root times a square will cancel each other out, and you'll be left with the radicand, or the number inside the radical. The radical is the division looking sign here. Right? Plus b squared equals 16. Then I get 8 plus b squared equals 16. Subtract 8. And I get b squared equals 8. Take the square root of that. And then this is where you need to be able to simplify. Square root of 8. I don't know how you've been taught how to simplify radicals, but there's 2 ways to do this. One, you can figure out what perfect square goes into 8, and you can write it out as the square root of 4 times 2 when you realize 4 is a perfect square. Or sometimes, if you're not best with your multiplication table, you can do a factor tree. So you can say 2 and 4, and then 2 and 2, and then it takes 2 of the same numbers to come out. Regardless, you get to the same outcome. If I take this 2 out, it's the same thing as saying the square root of 4. I would then have a 2 left over in each situation, so that would stay inside the radical. So you find your perfect square, pull it out, and then whatever's left is our leftover. So our b here would be 2 square roots of 2. After that point, you want to label everything. So this would be your opposite, this would be your hypotenuse, and then this leaves this as the adjacent. So when you're trying to find your 6 geometric functions, sine theta, again, is equal to opposite over hypotenuse. So in this case, again, I'm just abbreviating at this point even more. And again, I remember this from just the SOHCAHTOA. Again, it's just an easy little acronym for us to help us remember things. All right, so this would just be 2 square roots of 2 over 4. And then you just simplify. 2 4 simplifies down to the square root of 2 over 2. There's your first answer. Then you come over here and you do cosine theta, which is going to be adjacent over the hypotenuse, which in this case, again, is 2 square roots of 2 over 4, which comes out to square root of 2 over 2. All right. Then we have tan theta, and that's going to be opposite over adjacent, which in this case would be 2 square roots of 2 over 2 square roots of 2, which is 1. Now, to find the other 3, you would then do cosecant of theta. Here's another thing to help you remember which one goes with which. S and C, or C and S. You cannot have 2 S's together, and you cannot have 2 C's together. So if I have a sine theta, it's going to go with cosecant. If I have a cosine, it's going to go with secant. And then the last one will just be cotangent, but it goes with tangent. All right, so again, this is the opposite. So this will be the hypotenuse over the opposite. Now, you can do this in one of 2 ways. You can write it out like this and say 4 over the square, 2 squared to 2 if it helps, or just remember that cosecant is the inverse of sine. So I can technically take my sine answer and flip the fraction. If you don't do that and you just do this, you'll eventually do this and simplify it to this point. After that, we cannot have square roots on the bottom. So let me pause there. Yeah, you can't have square roots on the bottom. Some books do allow it, but not this one. Further down in your math career, we get to a point where we just stop rationalizing just because the numbers are just getting bigger and bigger on us. But in this case, we do need to rationalize. So I'm going to multiply the top and the bottom by the exact same square root. When you do that, you get 2 square roots of 2 over 2. So the whole point of multiplying by the exact same radical is to get rid of the radical itself from the bottom. Let's do a periodic, make sure I'm okay. All right, so again, then you see that the 2's cancel, and I'm left with the square root of 2. Then you come over here to secant, and that would be hypotenuse over adjacent, or again, remember that it's the inverse of cosine, so that's 2 over square root of 2. We've already done the work, so go ahead and write out your answer. No need to do it again. And then tangent is, or cotangent, sorry, is adjacent over opposite. And in this situation, a inverse of 1 is 1. To help you with that, there's a little side note. You can put a whole number over 1, and then when you flip it, you end up getting 1 over 1, which is right back to 1. Right? That doesn't mean every whole number will be the same, because if this was a 2, so again, a side note, then that would turn into 1 over 2. All right? So just something to think about when you're looking at whole numbers. And then there you go. There's all of your numbers. So let's do a few more. Here is our triangle. Here's our square. And if you didn't know this already, the square means that's perpendicular, so therefore it's a 90-degree angle. Here's our theta, 5 and 12. All right, so there's other things too you're going to find out also in trigonometry, is that we have certain triangles that are perfect and some that are not. If you don't remember it, totally okay with me. I actually only remember one of the perfect square triangles, which is the 3, 4, 5 triangle, but there are others. But again, if you don't remember it, you can plug it in again to your Pythagorean theorem. Again, this is the only side that matters, so this has to be the C. These can interchange between A and B. So this is going to be 5 squared plus 12 squared equals C squared. So that's 25 plus 144 equals C squared, which is 169. And then you would just take the square root of 169 and you get 13. All right, so this is one of those famous perfect square triangles, 5, 12, 13. But again, I didn't remember that, and I don't expect you to remember that. I do expect you to be able to get to the same conclusion, though. All right, so this right here will be the opposite. This will be the hypotenuse, and this would be the adjacent. All right, so now let's go through the work. Again, SOHCAHTOA to help you remember. Sine theta would equal my opposite over my hypotenuse, which in this case would be 12 over 13. Simplify if you can, but I can't. And then cosine of theta is adjacent over hypotenuse, which in this case would be 5 over 13. Can't simplify. Tangent of theta is equal to the opposite over the adjacent, which in this case would be 12 over 5. And again, can't do anything with it. Do our inverses. So again, that's cosecant theta, which again, just flip the fraction. It's 13 over 12. Secant theta, flip the fraction, you get 13 over 5. And then cotangent theta, flip the fraction, you get 5 over 12. Again, simplify if you can. Can't simplify any of those. Super easy to work with. And then we move on. All right, so let's do another one. Let's look at number 3. All right, here's our little triangle. 90 degrees here. Here's theta. Here's my 8. And here's my 6 square root of 2. Again, do some pre-work. This is the only side that matters, so this has to be my C. So that's going to be 8 squared plus B squared equals 6 square root of 2 squared. Again, it doesn't matter which one you let this be, A or B, you get the same conclusion. All right, so again, this is 64 plus B squared. Apply the square to both, so this becomes 36 times 2. So I get 64 plus B squared equals 72. Subtract your 64. So I get B squared equals 8. Take the square root of 8. We've done this already, and hopefully you get 2 square roots of 2. And you'll see a lot of common square roots, so you can quickly get the answer. Alrighty, so once we have that, just label your stuff. So this is my opposite, this is my hypotenuse, this is my adjacent. So I have sine theta, again is so that's my opposite over my hypotenuse, which in this case, again, is 2 square roots of 2 over 6 square roots of 2. Square roots will cancel. 2 over 6 is 1/3. Then do your cosine, which is the ca, so that's adjacent over hypotenuse. So that's going to be 8 over 6 square roots of 2. Simplify first to make your life simple. So this will be 4 over 3 square roots of 2, then rationalize. So that would give me 4 square roots of 2 over square root of 2 times square root of 2 would be 2. You can do one of two things. You can simplify at this point or simplify later. I'm going to simplify at this point. The 2 goes into the 4 2 times, so then I get 2 square roots of 2 over 3. If you went ahead and made that a 6, then your 4 over 6 would still go down to 2 over 3. Whatever process you go through, as long as you get to this point. Tangent of theta is OA, or TOA, sorry, is opposite over adjacent. And so that would be 2 square roots of 2 over 8. And again, that's just going to be square root of 2 over 4. Then do our inverses. Cosecant of theta, just flip the fraction. So that becomes 3 over 1, which is just 3. Cosine of theta, flip the fraction. So that becomes 3 over 2 square roots of 2. Now we do have to do a little, actually, what would be easier in this situation for you? I could finish out this process. So we'll do that. We'll finish this process out. So I get 3 square roots of 2 over 2 times 2. And I can't go any further, so it's going to be 3 square roots of 2 over 4. There's your first answer, right? Here's a little side note. Since I know cosecant, oh, I wrote cosine. This is supposed to be secant. Uh, If I know that secant is the inverse of cosine, which is adjacent over hypotenuse, then this would be hypotenuse over adjacent. Plugging in what I know, I can get 6 square root of 2 over 8, and then simplify that as 3 square root of 2 over 4. You get the same conclusion no matter which direction you go, just whichever one you're comfortable with. The issue is not one way is the best way. There's multiple ways to get there and multiple different ways that are easier for different situations. So play around with however you like to play around with it to get better and quicker with your math. All right, so here's cotangent of theta. Again, I could flip this, and again, it doesn't help me either way. This time it did, this time it won't. So I'm going to actually do 4 square roots of 2, and then I'm going to rationalize. So I get 4 square roots of 2 over 2, which then just gives me 2 square roots of 2. All right, so flipping the original one here doesn't help me like it did if I would have done it with secant. All right, let's do one more to make sure you fully have this down. So let's look at number 4. All right, so let's go right into Pythagorean theorem. So that's 2 squared plus b squared equals 4 squared. That's 4 plus b squared equals 16. B squared equals 12. Square rooted. Again, I don't know what your best. I'm gonna go with this way because I feel like this is the way y'all remember the most. 3 and 4. 4 is a perfect square. 3 is not. So therefore, the square root of 4 would be 2, and then I would have a 3 left over. Again, if you need to finish that off and say 2 and 2, and then circle it and make it a 2 and write a 3, go with whatever process you need to do. All right, so once you have your b, this is going to be 2 square roots of 3. And then here we go. So sine theta is well, I forgot to label. Opposite, hypotenuse, adjacent. So again, sine is so that's opposite over hypotenuse. So it's 2/4, which gives you 1/2. Cosine theta is cos, so that's going to be 2 square roots of 3. It's the a over the hypotenuse, which is 4, which comes out to square root of 3 over 2. Tangent of theta is going to be TOA. That's going to be 2 over 2 square roots of 3. 2's will cancel. When this happens, you're still left with a 1. So this is 1 square root of 3. Now rationalize. So I get the square root of 3 over 3. Cannot simplify that. One's in a radical, one is not. Cosecant of theta will be the inverse of 1 over 2, which in this case is just 2. Secant of theta would be the inverse of this. The original one doesn't make it any easier, so I'm just going to go with this process here. So once we flip it, we have to rationalize it. So this gives me 2 square roots of 3 over 3. Oh, cotangent of theta. Now I can flip this one and work it out, but here I see I could flip this one. So I'm going to go with 2 square roots of 3 over 2, and I get straight up square root of 3. I could flip that one, do the same work, and get to the same conclusion. So square root of 3 over 3 flipped is just the square root of 3. However process you want to go about doing it. All right, so I think you're pretty good with that. So let's move on to a different type of question you'll be exposed to. So let's look at number 15. All right, number 15 says evaluate the expression using a calculator if necessary. Rationalize all denominators in your answer. So it says, so evaluate the expression, sine and cosecant of pi fourths. All right, here we go. Sine of pi fourths. And then we have cosecant of pi fourths. So in the next section, I'm going to talk to you about the unit circle. But what is needed to be remembered here from your trigonometry days is here's your unit circle. And I'll go in more depth in this on 7.3. But this angle right here represented pi fourths. That was a 45-degree marker. All right. The coordinate of this guy, and again, I'll go into more depth in the next video, but this is the square root of 2 over 2, comma, square root 2 over 2. With this coordinate, we write coordinates with cosine of that theta, comma, sine of that theta. So to get the exact answer here, knowing this information from your trigonometry days, this right here is my answer to the sine pi 4. So that would be the square root of 2 over 2. I'll teach you a way how you can memorize everything here in an easier manner. Once you determine that sine is the square root of 2 over 2, cosecant, I would just flip the fraction. So that becomes 2 over the square root of 2, and then we would just rationalize that. So that becomes 2 square root of 2 over 2, which is just the square root of 2. It says use the calculator if you have to, but pi fourths is not one that you have to use a calculator with. And again, when you get to this part, you can look at the 7.3 video and you'll see us at the very beginning build the entire unit circle. And again, trigonometry has a it's not assumption that you have the unit circle memorized already. All right. But I will do a mini lesson in the next video. All right, so that's one type of problem you'll see, and it kind of goes back to your old math skills. So let's look at number 45, a different type of problem you'll see. It says determine the value of the given trigonometric function given the value of another trigonometric expression, and then it says round your answer to 4 decimal places. So you are asked to find sine theta given that cosecant of theta is equal to 8.7. All right. So to find out what sine is, you got to remember that cosecant is the inverse of sine, but then sine is the inverse of cosecant. That's how inverses work. They can go back and forth. So this is actually going to be the same thing as 1 over 8.7. So when you type that in the calculator, 1 divided by 8.7, you actually get how many decimals? 4.1149. And you just simply just take that and you just plug it into a regular 4-function calculator or your Inspires or however you need to write it out as. Okay? So that's all you got to remember. Cosecant being the inverse just becomes 1 over that. All right, then the next couple of questions are your word problems. This homework definitely likes word problems. Let's look at number 58, though. It says we're going to use appropriate trigonometric functions and a calculator, if necessary, to solve each of the following problems and round our answers to 2 decimal places. Number 58 says a mai is hooked on a 70-foot fishing line, 10 feet of which is above the surface of the water. The angle of depression from the water surface to the line is 40 degrees. How deep is the fish? All right, so let's draw this out. So again, see, my is hooked 70 feet of fishing line, 10 feet of which is above the water. So this is what I'm looking at. Let's draw a boat. I don't judge us drawing. There's a guy fishing. Fishing line. And then we'll draw our little fish here. It's got a little hook. This fishing line is 70 feet long. And it says 10 feet of which is above the surface. So here's 10 feet. So if you really want to write this out, you can add in that then this part here is 60 feet. You're then told the angle of depression from the water's surface to the line is 40 degrees. how deep is the fish? So what you're trying to do is figure out how deep is this fish? So there is our work here. So knowing or maybe remembering how triangles work with similarity. If this guy is 40 degrees for this little bitty triangle, since it's within inside this bigger triangle, that means that this will also be 40 degrees. Okay. And so knowing that fact, let's see if I have enough information here. Because technically what we're looking at is a triangle, because this would be a right triangle right here. This would be the opposite side that I'm looking for. This would then be the hypotenuse, leaving this with the adjacent. I'm given the hypotenuse. I'm given the angle. And I'm given this opposite side here. So let's go with this. So when I'm looking at SOHCAHTOA to solve these guys, 40 degrees has an opposite that I need and a hypotenuse given. That's going to be my SOHCAHTOA, my SO. So that's going to be sine of my 40 degrees. That's what that theta is. And we're going to set that equal to opposite of what I need over the 70 feet. All right. Now, when I do this, I just need to multiply both sides by 70. Now, we don't know what sine of 40 degrees is, so we have to type this into our calculator. Ooh, looking for the opposite here. So let's bring that out real quick. Give it a minute to load. I didn't have my calculator up already. But when using your Inspire, there is one thing you do need to keep in mind, especially when dealing with trigonometry. So let me switch over here. Right. Okay. So in your calculator with an Inspire, there's this thing right over here that says degree and radians. You can just click on it and it changes it automatically. Since I'm dealing with sine of 40 degrees, I need to make sure it is in degrees. All right. Once I have that, I can then type in what I have. So that's 70 times right here next to the 7 is your trig buttons. So then you can select your sine and then you would plug in your 40 for 40 degrees. You do not have to put the degree sign since your mode in your calculator is in degrees. And when you hit enter here, we see that it is 44.9, what did it say, 2 places? Okay, then that actually makes it 45. So here we go. So let me go back to my screen. All right, so this entire part here, this opposite part is, we're going to say 45 feet. Now, here's the issue. The question says, how deep is the fish? So the entire part here is 45. I just want this part. Ooh. So again, with similar triangles, they are proportional. So now this is what we will do. We have a triangle of 10 feet and an unknown side that we need to subtract to figure out what this side is. So what we're going to do is we're going to do 10 over this unknown value. And because they're similar triangles, it has to equal the entire length, which in this case is 70, over the entire length, which we just discovered is 45. We then cross multiply and divide. So we're going to cross multiply this. So that gives us 450. That gives us 70x. Doesn't matter which side you put the results on as long as you're multiplying their diagonals. Now I'm going to divide that. And that would be 450 divided by 70. Ooh, give or take. Again, what we round into two, that gives us 6.43. So 6.43 feet. So that's what this is, 6.43 feet above the water. So to figure out how deep this is, the last step of this type of problem is going to be 45 minus 6.43. So that's going to be 45 minus 6.43, and that gives us 38.57 feet. All right, so definitely a process to figure out how deep the fish is. Again, you had to find out that missing long side so that we could get to a point where we could set a proportion. We didn't have enough information to be able to set a proportion up with just the fact that that was 10 and 70 in total. All right. So in hindsight too, we also didn't need the 60, but it's always good to throw all the information in there so you can figure out what you do need and what you don't need. All right, let's definitely do more of these. So let's look at number 62. All right, number 62 says the builder of a parking garage wants to build a ramp at an angle of 16 degrees that covers a horizontal span of 40 feet. What is the vertical rise of the ramp? These type of problems, best way to do, draw a picture. All right, so again, not the best drawer, but again, the builder of a parking garage wants to build a ramp. Here's my ramp of an angle of 16 degrees. So this angle here is 16 degrees. And it has a horizontal span. So horizontal, think of the horizon. So it has a 40-foot span. What is the vertical rise? So that would be this guy. All right. So let's label our 90-degree triangle. So again, we know this is 90. This is my theta, and this is a degree, not 160. I don't know if it's going to be better if there we go. Make that degree sign a little bit smaller. There we go. So 16 degrees. So we know this is theta. That means that this is the opposite. This is the hypotenuse, and then this is the adjacent. All right. So when we're working this out, here's your SOHCAHTOA as a reference. You are asked to find the opposite, and you are given the adjacent. So you look at, all right, what deals with opposite and adjacent, and hopefully you go with tangent does. So this now becomes tangent of 16 degrees, because that's your theta, equals my opposite, which I don't know, over my adjacent, which is 40. Solve it, and you get 40 times tangent. I don't know 60 degrees, so now we jump back to our calculator. Make sure you see. Okay, so again, we just type in 40 times, again, the trig function's next to the 7. This time we'll hit tangent, and we'll do 40 tangent of 16 degrees. And that gives you, again, they want us to round to 2 decimal places. So that's going to be 11.47. So we'll jump back. So that gives us 11.47 feet of a vertical rise on the ramp. All right, let's do a few more to make sure we fully got it. Let's look at number 65. Number 65 says a radio tower has a 64-foot shadow cast by the sun. If the angle from the tip of the shadow to the tip of the tower is 78.5 degrees, what is the height of the radio tower? So again, let's draw our stuff. So we have a radio tower. This is my radio tower. Just a straight line. Don't have to be fancy. Has a 64-foot shadow cast by the sun. All right, here's the sun. So that means here's the shadow, 64 feet. If the angle from the tip of the shadow to the top of the tower, so that's talking about this guy, so the tip of the thing. Here we go. So again, it says, again, if the angle from the tip, the tip of the shadow to the top of the tower is 78.5. So that's this guy. So again, this is from tip of shadow to the top of that as a 78.5 degrees. What is the height of the radio tower? All right, so here we go. So this is my opposite. This is my adjacent. Here's my angle. O and A deals with TOA. So that's going to be tangent of 78.5 equals opposite over my adjacent. So multiply both sides by 64. And then I come back and I need to bounce back to the calculator. So again, that's going to be 64 times, was it 64, right? Where are we at? Number 65, 64, yeah. All right, times the tangent of 78.5. And that tells us our tower is 314.57 feet. All right, so again, that's going to be 314.57 feet in the air. All right. So let's do a couple more again to make sure we have it down. I want to make sure you have plenty of examples. So let's look at number 67. Again, this says the ramp of a moving truck touches the ground 12 feet away from the end of the truck. If the ramp makes an angle of 30 degrees relative to the ground, what is the length of the ramp? So again, ramp of a moving truck touches the ground 12 feet away. So that means here's our ramp. Here's a truck 12 feet away, touches the ground. If the ramp makes an angle of 30 degrees relative to the ground, here's my 30 degrees to the ground, what is the length of this ramp? So I'm looking for this guy. All right, so though, again, this is your opposite, hypotenuse, this is your right, and then this is your adjacent. I am looking for something that has adjacent and hypotenuse. So again, you look at your SOHCAHTOA, and hopefully you're like, all right, that must be a cosine. So we're going to do cosine of 30 degrees equals my x over 12. And now I'm going to multiply both sides by 12. So again, we just jump back to the calculator. And we'll do 12 times trig cosine. What was it again? 30 degrees. And so the length of it would be 10.39. And I don't remember what the units were. I want to say feet. I didn't write it down there either. So 67, yeah, feet. Okay, so this is feet here. So then this would be 10.39 feet long would be the ramp itself. All right. After that point, now it's working on number 68 will be the next one. And then I think there's only one more after that. I think we've done them all. All right, so 68 says the angle of elevation of a flying kite is 61.7 degrees 21 seconds. So 71 degrees 7 seconds 7 minutes 21 seconds. If the other end of the 40-foot string attached to the kite is tied to the ground, what is the approximate height of the kite? All right, so it says the angle of elevation of a flying kite. So here is my kite. Here is my string. All right, so it says again an angle of elevation of a flying kite. Elevation means it comes from the ground. So the angle of elevation of a flying kite is 61 degrees, 7 minutes, 21 seconds. If the other end of the 40-foot string, so this is a 40-foot string, is attached to the kite to the ground, or so this guy has it to the ground then, what is the approximate height of the kite? So then we're trying to calculate this guy. All right, so in this order, you have to turn this into degrees. Now, again, it's like that type of thing where they expect you to know how to do this already. But let's talk about what we call DMS, degrees, minutes, seconds. So to figure out what this is in degrees, you just have to do 61 degrees plus there is 60 minutes in 1 degree. So you would do 70 divided by 60. Plus there is 21, there's 60 seconds in 1 minute. So therefore there is 3,600 seconds in 1 degree. All right, before I finish that part, let me make sure. Yeah, okay. Make sure I gave you the right number, 3,600. And then you just add those up. So in our calculator, we'll do 61 plus 7 divided by 60 plus 21 divided by 3,600. And I want that to be a decimal. So that would give you 61.1225 degrees. All right, so here we go. Here's our theta. Here's what I need. This is opposite, and this is a hypotenuse. So opposite and hypotenuse will be sine. So this will be sine of 61.1225 equals opposite over hypotenuse. So multiply both sides by 40. Let's see what we get. So again, I'm just going to go back to the calculator. So this is going to be 40 times sine of 61.1225. And I get 35.0, I think we had to round to 3 decimals, so 3 feet off the ground. All right, last one. And again, I think y'all have all the examples y'all need. So number 73. It says a surveyor standing some distance from a plateau measures the angle of elevation from the ground to the top of the plateau to be 46 degrees, 57 seconds, or 57 minutes, 12 seconds. The surveyor then walks forward 800 feet and measures the angle of elevation and now be 55 degrees, 37 minutes, and 70 seconds. What is the height of this plateau? So here we go. So again, it says a surveyor standing some distance from a plateau measures the angle from the ground. I imagine a plateau being something like this, and this guy's over here. So a surveyor standing some distance away from this plateau, don't know the distance, from the ground to the top of the plateau is going to be 46 degrees, 57 minutes, and 12 seconds. Then it says the surveyor then steps back 300 feet and measures the angle of elevation to now be, where are we at? 55 degrees, 37 minutes, and 70 seconds. What is the height of this plateau? So I am trying to calculate what the height is here. Okay, so this is going to be a similar triangles because it's a triangle within a triangle. See, if we know this is 300, and this is going to be something. We have the angle here. Let's see, what information do we need? This isn't a right, so I can't just use that information. All right, so I know this is going to be 55 plus 37 over 60 plus 70 over 3600. This would be 46 plus 57 over 60 plus 12 over 3600. But given the angles, interesting. Let's see. All right, well, let's just figure out those angles. Well, maybe putting that on paper, we'll see it. So let's see, a 40, this would be 46 plus 57 divided by 60 plus 12 divided by 3600. This right here would give me 46.9533. The other one would be 55 plus 37 divided by, oh man, 55 plus 37 divided by 60 plus 70 divided by 3600 gives me 55.6361. All right, so I have this angle and I have this angle. I'm given this side. I don't know this, and I don't know this. Let's see. So again, a surveyor standing from some distance from the plateau measures an angle elevation from the ground to the top of the plateau to be that. The surveyor then walks forward. Oh man, I wrote that backwards. I guess I looked at number 74. So it says the surveyor then, did I get the right numbers? Okay. It says then the surveyor then walked forward 800 feet. All right. So that means that this guy walked forward 800 feet. And then now this angle is 55.6361. Okay. So he walked 800 feet forward. Surveyor then walked forward 800 feet and measured the angle to now be 55 degrees. Right there. What is the height of the plateau? So again, it's going to be 800 here, but I don't know this amount. I do know this would probably be equal to 800 plus some value. We'll call this value y since it's a different value. So 800 feet plus some distance. I'm trying to think, maybe this could be a proportion, but then you would still have like, all right, well, this would be 800 plus x, and this would be over x, but you still don't have like another side to be proportional with. You could maybe go with this would be the adjacent side, and this would be the opposite. So we know we're going to have something to do with tangent. If I have tangent of 55, then it would just be question mark over question mark. And then this one would be tangent of this of equal to question mark over 800 plus a different question mark. Hmm. Let's see. Do we get an example in the book like this? Let's look at example 6 then. So it says, approach from one direction. Mount Baldy rises out of a perfectly level desert plain. A surveyor staying at the desert some distance from the mountain measures an angle of elevation on the desert floor and then the top of the mountain to be that. She then walks back up 1,000 feet, determines the new angle. How high is the mountain? All right, so then they did. Oh, this is a formula. That's why it's not one of our normal. So the formula here would be our height. Let's see. So the distance would be for us 800, and this would then be um, cotangent of our smaller degree or our first degree, which would be 46.9533 minus the cotangent of 55.6361. And then that would give us our answer. All right, so let's plug that in the calculator and see what we get. So I'm going to do control divide to make it a gigantic fraction. Oh, this is also again a gigantic fraction. So that's going to be 800 over our cotangent. And this would be 46.9533 minus our cotangent of 55.6361. And that tells us then that our height is 3,196.79 feet. All right, so I wonder we got stuck there. It wasn't our typical one. There was a formula that we just didn't know. All right, and there you go. If there's any other questions you need me to go over, let me know. In the next lecture, I will go over in more depth on the unit circle. All right, until the next video.